Hello students, welcome back to my channel Ravi Maths Great. As in my previous videos, we have discussed the last video that was based on the topic relations and functions, in which we discussed the sums based on 1 and onto concept. Now today I'm going to discuss a very most important topic for the 12th class, that is the topic integration. Now, as we have the list of the formula of integration in the book itself, I'm not writing the same on the board. I'm discussing the questions but with some few different techniques so that we can have the solution of the sums based on integration in a very easy, lucid manner. So, the first question, here it is. Exercise 7.2. The first question, I is equal to integration 2x upon 1 plus x square. Now, a very simple method which we can use to crack especially the MCQs is that if we go through the differentiation of the denominator part, in the denominator we have 1 plus x square. If we take the differentiation of 1 would be 0 and the differentiation of x square is 2x, which is available in the numerator. So, if the differentiation of the denominator part is available in the numerator part, we can write directly log of the denominator part plus c, where c is a constant of integration. So easily we have obtained the answer. So what is my trick? What I did, I saw that the differentiation of the denominator part is available in the question, so I replaced there with log. The second question, I is equal to integration, we have log x whole square whole upon x dx. Now children, sometimes the things are very easy and sometimes it is a little bit tricky also. So what's the trick here? We have heard the word log x, but we have not heard the word log x ka whole square. So what should we do? We will put log x is equal to t. So the next question would be, Ravi sir, why to take log x is equal to t? So the very simple rule is that whatsoever you put t, its differentiation must be available in the question. So if I am writing put log x is equal to t, its differentiation would be 1 upon x dx is equal to dt. So this is log x can be replaced by t square and dx by x is t. So what is integration of t square? Integration would be t cube by 3 plus c. Got it? The formula is of x to the power n, that is x to the power n plus 1 upon n plus 1. Now we have to replace t by the original one, that is log x whole cube by 3 plus c. This complete our question number 2. Now I am doing question number 3. I is equal to integration 1 upon, so I am writing dx upon, we have x plus x log x. So I am taking out x to be common. So in the bracket it would be 1 plus log x. Now what we can do, we can write this x to be like this 1 slash x in the numerator. Now why I took this much pains? Because the differentiation of the denominator part is available in the numerator part. Because log x differentiation is 1 by x, which is available. So we can write log of the denominator part directly. And that is the answer. Now the fourth question, let us proceed. I is equal to integration sin x sine of cos x and dx. Now again the same story in this one, to whom which we have to consider to be t. So it is very simple. We have heard so many times sin x, cos x, but we have not heard sine of cos x. So what seems to be odd? That word cos x. So that cos x we are going to put to be t, like this. Put cos x is equal to t, differentiation would be minus sin x dx is equal to dt. Now this sin x and this dx can be replaced by this expression with minus sign outside the bracket. So sin x and dx will be replaced by dt. This is sine of, this is cos x, which is t. Now what is integration of sin t, my child? The integration of sin t is minus cos t. Already we have minus sign, so minus of minus will become plus. So cos of, now we have to replace t by the original one, that is cos x plus c. This complete our question number 4. Now few sums which are very easy. In those sums I am going to write only what to put. So just note down and try yourself. In the question number 5, you people should try by putting sine of ax plus b is equal to t. Okay. So in the 6th one, it is I is equal to integration. I can replace by under root by to the power half. So what I have done, I have done simple modifications. In the original question, it is given under root ax plus b. So I wrote there ax plus b whole to the power half. Now what sort of formula we can apply? Amongst the list, we have the formula of x to the power n. So what we can do? We can write to the power n plus 1. So half plus 1 whole upon half plus 1. Now here we have to apply the chain rule. We have assumed ax plus b to be x itself. So we have to do the differentiation of that expression. So the differentiation of x is 1 to be multiplied by a. In the case of differentiation, we used to do multiplication. And in the case of integration, we have to divide it. So we'll divide the whole expression by a plus c. So now the simple calculations are there. Half plus 1, it becomes half plus 1, that is 3 by 2, 2 ones are 2 plus, that is 2 by 3 times ax plus b whole to the power 3 by 2, a is there plus c. So children, this complete question number 6. Now the question number 7. Now question number 7 and the question number 11 are of the same pattern. So what's the pattern? Let me explain you. It is integration x time under root x plus 2 and dx. Now what's the moral of the story in this particular question? If we go through the power of x, individual power, here we have to the power 1, even inside the under root, and the power is 1, that means we can say the powers are same. So whenever we have the same powers, what is the procedure? Just check. I is equal to integration, what is there with x? Plus 2 is there, so I am writing plus 2 with this x, and to compensate this plus 2 I am writing minus 2 with the same one. Now if we go with the multiplication process, first the multiplication of this under root with this expression. Here the power is 1 and under root, that means power is half. So 1 and half, it will become 3 by 2 with dx. Now the multiplication of this under root with minus 2. So I am writing this minus 2 outside and only under root x plus 2 would be there. And I am writing it as x plus 2 to the power half. Any confusion? I hope not. Now after that, it is easy. We have to apply the formula of x to the power n, that is x to the power n plus 1 whole upon n plus 1. So that will complete our question number 7. Now after this I will solve directly question number beta 11. So let me clean the board. Yes student, अब हम करेंगे हमारा question number 11. So the question number 11, as I said, it is just equivalent to the question number 7 which we did just now. Again the same procedure is there. We have x plus 4 in the denominator and x is there in the numerator with the same power. So there we did plus 2 and minus 2. Here we have plus 4. So we'll do x plus 4 and minus 4 whole to be divided by under root x plus 4. There we did multiplication process. Here we'll do division process. So this x plus 4 to be divided by under root x plus 4. Got it? And that means I have done division of this much portion. Minus 4 times dx upon under root x plus 4. That is the story. Now here I can write this is with root and this is without root. So after the cancellation we will have x plus 4 whole to the power x minus. Now my child, few formulae are there which are not available in your book list. You can say the formula modified by Ravi sir. So let us have a glance of the first one. My formula, integration of 1 upon root x bache. It is 2 root x. Actually this formula is not there in the book list. So I tried that I should find out something so that my children can get the answer in a very easy manner. So my formula, which I've modified from the original one, is dx upon 1 by root x, which is 2 root x. So this concept we can use in this particular step. This is 1 by root x. It would be 2 times of this and plus c. So here it would be x plus 4, half plus 1 is 3 by 2, whole upon 3 by 2, and rest is children copy paste. So this we have completed question number 11. Now I am going to continue the question number 9th one. So let us try to understand what to do in the question number 9. In the question number 9, if you go through the question, I am writing little bit modified version. In the question, it is given in the bracket 4x plus 2. What I am doing, I am taking out 2 as common. So I will write in this manner, 2 integration, in the bracket it would be 2x plus 1, but I cannot do anything inside the square root. Let it be as it is, that is x square plus x plus 1. So up to here what we have done, we have taken out just 2 common from the first bracket. Now as I said, to what expression to be assumed as t, that is the main goal to crack the question. So the main that trick is, whatsoever you assume to be t, its differentiation must be available in the question. Now the student may get confused that Ravi sir, can we have this under root x square plus x plus 1 to be t? No my child, because if I write under root, that means we have to start the differentiation process with the under root, and that is not my fruitful way. So what should I do? I will write only x square plus x plus 1 to be t. Done. Why Ravi sir you have chosen this to be t? So my child, make the things clear, make the vision that if I will do the differentiation of this core part inside the under root, it would be 2x plus 1. Oh yeah, it is available there. That will make my calculation part easier. That type of vision is required, beta. Got it? Now proceed. So I is equal to 2. Now we have the expression here and here. Now these two can be replaced by dt. And my child, don't put this type of tick mark. That is the part of the evaluator. Let him do. I have done this much to show you. Then too, if you want to do in this manner, use the pencil. And this under root portion to be replaced by t to the power half. Now rest is okay. That's not a big deal. We can have the formula of x to the power n. That is our homework part. Now let us continue the 10th question. Now in the 10th question it is given, beta, dx upon x minus root x. Got it? What we can do, we can have this root x common. This is x. As I have taken this root x to be common, it would be root x minus 1. Any confusion, children? Now I can shift this root x in the numerator part. So this is root x minus 1. Now children, tell me, what would be the differentiation of the denominator part? So my children will say, Ravi sir, we do not have the formula of root x differentiation. So bacha, it is in the Ravi sir's list. So a modified version again, d by dx of root x. All of you please learn it. It is 1 by 2 root x. I repeat, the differentiation of root x is 1 by 2 root x. Now fortunately I have 1 by root x in the numerator. Then what's the problem? The problem is lying with the digit 2. It is not there in the question. That can be modified in the next step. So I'm writing here, as due to lack of space I'm not able to continue the sum here. So I'm doing it this side. So this is 1 by 2 root x times root x minus 1 and dx. So Ravi sir, you have done multiplication by your own. No problem. I can shift to compensate this too. I'm writing here too. So now as I got the differentiation of the denominator part, I can write log of the denominator. And bacha, this completes my question. Now we'll do the next question. 11th I have already explained you. We'll solve question number 12th after it. Okay. So question number 12. Yes children, now let us continue the sums. Now as few questions are very easy, I am just giving you the hint what values to be put. In the 12th question, the hint is put x cube minus 1 is equal to t. In the 13th question, the hint is put 2 plus 3x cube equal to t. The 14th question, put log x is equal to t. In the 15th, put 9 minus 4x square equal to t. 16th is the direct question. In the 17th, put x square is equal to t. In the 18th question, all of you please note down, put tan inverse x is equal to t. So I would like to solve question number 19th for you people. So question number 19th, I is equal to integration. This is e to the power 2x minus 1 whole upon e to the power 2x plus 1. So this is a question children. Now how to solve? In this we have a simple trick. Divide numerator, all of you please note down, divide numerator and denominator by e to the power x. So how to proceed? We'll write integration. If I will divide e to the power 2x by e to the power x in this manner, same story here, whole upon in the denominator also, same procedure, and dx. So e to the power 2x divided by e to the power x, that will give e to the power x. Here I am shifting this one to the numerator side to become negative, and same story in the denominator. Okay children, now the things are very easy. If we go through the differentiation of the denominator part, e to the power x, the same e to the power x which is available in the numerator, and e to the power minus x, again e to the power minus x, but by the chain rule we have to do the differentiation of minus x, that will give minus 1, that is minus e to the power minus x, which is altogether available in the numerator. So children, as a differentiation of the denominator part is available in the numerator part, we can write children directly log of the denominator part. This complete your question. In the same manner, we can proceed for the 20th. So the 20th question is, this is e to the power 2x minus e to the power minus 2x, e to the power 2x plus e to the power minus 2x. That is the story. Now how to proceed in this particular sum? Let me check whether I have copied correctly or not. So yeah, with the grace of God, all things are right. Now if we apply the same procedure what we did here, if we compare this step with this one, altogether all things are same. Instead of x we have 2x. Done. So if we do the differentiation of the denominator part, what would be the differentiation of e to the power 2x children? Ravi sir, same e to the power 2x. And as per the chain rule, the differentiation of 2x would be, 2. That means we are lacking with 2. Yes, and that can be adjusted very easily. How come? We'll multiply the numerator part by 2, as it is a demand of the question. But it is not like that. I have to compensate it also. So I'm dividing it by half. So this is half. And now the differentiation of the denominator part is available in the numerator part. So it would be log of this part. This complete your question. Done? Short and simple trick. Because this time actually you people will get 18 MCQs, and many times during the process of the application of integrations, or in the case of differential equations also. So there, to make the sums in the solution pattern very fast and very quick manner, these tricks are very fruitful, children. So now I would like to continue with the next question, 21. So look, question number 21. I is equal to integration tan square of 2x minus 3 dx. Now children, if you go through the list of the formula of integration available in your book, unfortunately we do not have any formula for integration of tan square theta. So what to do? We have to recall the identity which we have studied in class 10th, and that was 1 plus tan square theta is equal to sec square theta. Am I right? So we can replace this one by sec square theta minus 1. Got it? So here what we have done, we have used the trigonometric identity of 10th standard. Done? Now, if we go through the list of the formula available in our textbook, we'll find that sec square theta integration is available. It is tan theta. But it is not theta or x, it is 2x minus 3. Again, by the chain rule, I have to differentiate this one. The differentiation of 2x would be 2, and it has to be divided by 2. And the integration of 1 is x. Everyone knows very well. So this complete question number 21, children. Now, 22 is very easy. So in 23rd, just note down the hint. Easy. Put sine inverse x is equal to t. That is the hint, children. Even I would like to give you hint in the few more questions, but I think now I should clean the board. After that I will explain you the 24th onward sums. Okay, let me clean the board. Yes, children, now the story of question number 24th. In the question number 24th on the board, what I have done, I have taken out 2 common from the denominator. If you go through the original question given in the book, we have 6 cos x plus 4 sin x in the denominator. So what I did, I take out 2 common. After taking 2 common from the denominator part, children, just go through the differentiation of the denominator part is available in the numerator. 2 sin x, the differentiation is 2 cos x, and 3 cos x, the differentiation is minus 3 sin x. So again, my trick, we can write directly log of the denominator part. So children, this completes the question number 24th. Now in the question number 25, I am writing with little bit modifications. The original questions, it is given cos square x in the denominator. I am writing its reciprocal sec square x in the numerator directly, and I am copying the rest part as it is. Done, children? Now how to proceed? I will write, put 1 minus tan x is equal to t. Differentiation, tan x, the differentiation sec square x. So sec square x minus sign is there. Dx is equal to dt. So sec square x dx, it would be minus dt, children. So minus sign outside. This is dt. And the whole bracket we have assumed to be t. So t square, children. Now again Ravi sir's formula. D by dx of 1 by x. The differentiation of 1 by x, children, it is 1 by x square with minus sign. So from here we have concluded that integration of 1 by x square is minus 1 upon x. Got it, children? So 1 by x square, it is minus 1 upon x. Already minus sign is there. It would be 1 by t plus c. Now put the value of t to obtain the answer final. That is 1 upon 1 minus 10x plus c. This complete your question, children. And we have completed the 25th one. So let me check. Now few sums are very easy. So I'm just giving you the hint what to put, and that you people can try in homework. So the question number 26. Question number 26, put root x is equal to t. Then in question number 27, put as. Now in the question 27, children, we have under root sine 2x and cos 2x. So I would like to put sine 2x is equal to t. So my children may ask, Ravi sir, आपने sine 2x को t क्यों रखा? Because it is under root. It has under root sign. That's why. In the 28th question, we'll write put 1 plus sine x is equal to t. In 29th question, put log sine x is equal to t. Then in the 30th question, again put 1 plus sine x is equal to t, children. 31st, again the same hint. Now 32, 33, they are little bit different. Okay. So I am discussing those sums in which you have to put and you can get the answer very easily. So I am just switching over directly to 35th question. Put 1 plus log x is equal to t. Okay, beta. 36th question. Put x plus log x is equal to t. Then in the 37th question, put tan inverse x to the power 4 equal to t. So children, after 31st, I just switch over to 35th. So I have skipped 32, 33rd and 34th. So now I will explain in detail 32, 33rd and 34th. So let me rub the board. So now we'll do this one. So the (32) question. It's an important question, children. The original question is dx upon 1 plus cot x. Okay, now how to do it? First, we will convert the original question into sine and cos beta. So we will write dx upon 1 plus, I am replacing cot theta by cos by sine. After taking the LCM, it would be sine x plus cos x and sine x. Got it? A trick, or you can say a turning point, is there in this question. I am writing here half and there I am writing 2. Denominator copy paste. Now if I go through the question, in the denominator I have sin x plus cos x. So what can I do? I am writing this as sin x plus cos x to be divided by sin x plus cos x plus, actually in the previous step 2 sin x was there and here I wrote only sin x. So I am writing again sin x. Then your next question, ki Ravi sir, cos x is there, but in the previous cos x was not there. Okay, no problem. I am compensating that cos x also by writing here minus cos x. And the denominator part, I have copy pasted this one. Done. It's a nice question, beta. So all of you please try this question at least twice or thrice in writing. Then only you can crack this question. Now this expression and this expression will get cancelled out. So we will have 1. Any problem? Now again the ball's in your court. What is the differentiation of sin x, children? It is cos x. And the differentiation of cos x is minus sin x. The expressions are available in the numerator part but with opposite signs. So what we can do? We can have this minus sign common. So as soon as I will take out this minus sign common, it will become cos x positive and sin x negative. Any doubt? And in the denominator, it is sin x plus cos x. Are you getting my point? What I did, I have taken minus sign common from the numerator part, and the misconception is, so children, what I did, or what I want to say, that to take out the minus sign is not like that all the terms becomes positive. It's a misconception. To take out minus sign common, it means to change the sign. That means positive will become negative and the negative will become positive. Are you getting my point? So now nothing is tough. The things are easy. Half the integration of 1 is x minus the differentiation of the denominator part is available in the numerator part, children. So Ravi sir's idea, log of the denominator part, beta. And hence we are through. This complete your question number 30. Yes children, in the 33rd question I have just written the modified version of the original question. In the original question it is given 1 minus 1 upon 1 minus tan x. So I have converted this tan into sin by cos. After that I took the LCM. So this is the scenario. Now the same procedure which we did in the previous question. I am writing here half and there I am writing 2 cos x. The denominator part copy paste. I am not writing to save the time and to shorten the length of the video also. Now 2 cos x I am replacing by cos x minus sin x. So your next question would be children that Ravi sir आपको कैसे पता चला कि minus लगाना है? Bhai, it is available in the denominator. That's why. Plus again I am writing cos x. The compensation would be plus sin x, children. In the denominator cos x minus sin x. Done. Now I can cancel this part and this part, it would be 1. So integration big bracket, this is 1. Now here is a turning point of the question. This is cos x. Its differentiation is minus sin x. And this is minus sin x. Its differentiation would be minus cos x. Though we have those trigonometric ratios available in the numerator, but minus sign is not there. That is a problem. And we can find the solution in very easy manner. Just write down minus sign and inside the bracket write down minus cos x and minus sin x. And hence we are through. Then no problem. Now the things are very easy. The differentiation is available in the numerator. So here the integration of 1 is x and it would be minus log of the denominator part. So this complete the question, children. Now the 34th question. This question is very tricky question and I would like to give my sincere thank to my professor because he taught me this particular question long back that Ravi, you can solve this question with such a simple method also. So whenever I solve this question, I always I remember my professor. So continue. This is sin x cos x. That is the original question, but let me check. It is yeah, under root tan x upon sin x and cos x. So how to proceed? The trick is, my child, this part as it is. Divide this sin x by cos x. So to compensate that I have to write there cos x. One more cos x is there, children. So this is under root 10x. Now sin by cos will become 10x, and cos into cos beta, cos square x. Okay, so this cos square x I am replacing there in the numerator. It will become sec square x, children. So this is sec square x, and it would be upon under root 10x. Done. Now put 10x is equal to t. Its differentiation would be sec square x dx is equal to dt. So it would be dt upon root t. Got it? Now Ravi sir's formula, 1 by root t, that is 2 root t plus c. So after replacing the value of t, we'll get the answer. So here I have completed my first video based on the topic integration for class 12th of exercise 7.2. I hope my video would be fruitful for you people, but it's my advice to all of my children that before starting this exercise, just write down the formulae given in the book, try to memorize them, and the basic tip to memorize the formula is whenever you use a formula in any of the question, at the same time just write down the formula. As many as time you write the formula, you will be well versed. And don't forget to write the formula or memorize the formula explained with different pattern by your Ravi sir. I hope my video is fruitful for you people. So please like, share and subscribe my video, and we'll meet very soon. Thanks to all of you. Best wishes. We'll meet with our next video for the exercise 7.3 very soon. And don't forget to subscribe my channel, because you are the people. And yeah, with your love and support, we are getting very good number of subscriber, but the number should be enhanced more and more and more. So thank you very much.